All right, this is going to be quite the lesson. We are covering vertex and standard form of quadratics, both of which you've learned in Algebra 1, but that's been a while, so let's recap both of those. All right, so first I would like for you to remember and make a note. X squared is what's going to make the function quadratic, and the graph will be a parabola or a U shape. All right, so we're going to start with something that we know that we've already talked about, graphing things that are in vertex form. So this is called vertex form. And you don't necessarily need to remember the letters, but this, if you see a form that looks like this, that's what it's talking about, is vertex form. We call it that because it's really easy to see the vertex from it. Also, notice the negative on the inside is reminding you that inside is opposite. The plus sign on the outside is reminding you that the outside is the same. All right, so in this example, if we go to graph that, I'm going to go ahead and name, for transformations, I can do my fraction, -2/1. And then inside's opposite, outside's the same, that's 1/8. If we're going to label these, my -2 on the top is going to do two things. The negative is going to reflect, and the 2 is going to be a vertical stretch, reflect over the x-axis. The 1 is going to move me right, and the 8 is going to move me up. So we've actually already named the vertex here. The vertex here is 1, 8. The axis of symmetry here is x equals 1. Remember that axis of symmetry comes from the x part. The axis comes from the x part of the vertex. And if we try to graph this, which I'm going to do before we name anything else, we're going to go to start at our 1, 8 point. Should be, let's see, up here. And because my slope or my rate is -2/1, I'm going to go down 2/1. Now at this point, all we've talked about is how to make that first point. I'll just go ahead and tell you that pattern for quadratics is 1, 3, 5, 7/1. That comes from the difference of the first perfect squares, and if you'll make a note to ask me about that in class, I can show you. But because we're going down by 2s, in this particular instance, we're going to go down 2, down 6, down 10, down 14, if we had room. All right, so down 2, down 6, goodness gracious, down 10. All right, so notice we've got this very, very stretched parabola right here, and hopefully you can connect better than I can. The axis of symmetry is running down the middle. A few other things that I want to point out to you here. You can identify for yourself on your graph. This is the y-intercept at 6. These points down here on the x-axis are very important. We call those zeros. We also call them roots. Sometimes they're called solutions. All right, so in this instance, those would be at -1 and 3. And then lastly, if we talk about domain and range, my domain is going to go from -infinity to +infinity. Remember, that is how far left and how far right we are going. And then my range is how far up and how far down. So notice that my range is going to be, it goes down forever, so that's -infinity. But when I go up, it's going to cap out up there at 8. So it's going to go up to 8, and it's actually going to hit it, so that needs to have a bracket on it. So those are my domain and range. So I think you all are actually pretty good at graphing and finding all that information. Now I want to talk about how to write equations, so go the other direction. So this says we have an equation with a parabola with a vertex of 120 that passes through the y-intercept of 0, 4. So a few things about this. With that vertex of 120, I can go ahead and write most of my equation. Y equals, I don't know what goes in the front here, but I know that the rest of the equation should be x minus 1 squared plus 20, because inside's opposite, outside's the same. Now, the problem is I need to know what is in this spot right here. So to do that, notice they've given me the y-intercept, which has an x and a y value on it. The x value is 0, and the y value is 4. All right, so let me rewrite that in a new line. I have this equation, 4 equals some unknown. We're going to call that a, because that's what the format calls it. 0 minus 1 squared plus 20. So if we work this out, 0 minus 1 squared, that's just 1. So a times 1 plus 20 equals 4. Subtract 20 from both sides is negative 16. Divide by 1, so a is negative 16, which leads me to an equation, y equals negative 16 x minus 1 squared plus 20. All right, so now let's transition into standard form. And I'm going to use this equation just to show you we're going to do some things kind of with this same equation over and over again. So let's talk about how to change this equation into a standard form. And standard form, we'll talk more about this here in a minute, looks like ax squared plus bx plus c. So notice in standard form there are no parentheses, so that's what I'm going to need to do is simplify without the parentheses. So order of operations tells me I'm going to need to square this part first. Remember, when you do parentheses square, this is from Algebra 1, you have to write it twice, and you're going to double distribute here. So this is going to be x squared minus 1x plus 1, or x squared minus 2x plus 1. I have not done anything with this negative 16. It's still multiplying, and I haven't done anything with this plus 20. So I'm going to bring those down. Now it looks like I can distribute. So I'm going to distribute the 16, negative 16x squared plus 32x minus 16 plus 20. And now I can combine like terms to give me a final standard equation of y equals negative 16x squared plus 32x plus 4. All right. Now, before we go forward, there is one thing I want to point out to you, and that is that this plus 4 back here is not a coincidence. This plus 4 is the y-intercept of the parabola. And notice, if you look back at your notes, the original equation had y-intercept of 4. So that is not by coincidence, that is actually a part of standard form. And it is important that you note that. All right, so let's dive a little bit more into standard form and how we find information from it. So from vertex form, that would be this one on the left-hand side, from vertex form, we know that the vertex here is 120. And from the vertex, we know that the axis of symmetry is x equals 1. We don't know anything about the y-intercept. The other thing that we do know, though, from this side is that it is opening upside down. So the parabola is going to be upside down because there's a negative in the front. Okay, so now let's talk more specifically about standard form over here. We just said one thing about standard form, and that was that we know that the y-intercept is the c value. So my y-intercept is going to be equal to c. So in this case, it's going to be 4. So for standard form, we're actually going to work backwards. We don't have the vertex to start with. We're actually going to start with the axis of symmetry. And when we start with the axis of symmetry, you need to know that the axis of symmetry comes from the quadratic formula. And so I'm going to write that down real quick. And the axis of symmetry is just this first part, x equals negative b over 2a. At some point, you will have to memorize the rest of this here in a few days, but for now, we're just going to start with this x equals negative b over 2a. So a, b, and c, as you should have already noted, are those coefficients in the front. So if I'm finding this one, it's x equals negative b, so negative 32, all over 2 times a, which is negative 16. So if I simplify that, that's negative 32 over negative 32, which gives me 1. So my axis of symmetry is x equals 1. Notice that that is what we already knew, but that was when it was in vertex form. Okay, from that, we can now find the vertex. And to find the vertex, we're going to use the axis of symmetry in the equation. Okay, so what we're going to do is we're going to plug that into the x places. So 1 squared plus 32 times 1 plus 4. And if we simplify this, this is going to be negative 16 times 1 squared plus 32 plus 4. is going to give me an output value of 16 plus 4, which is 20. And so that's my y value, meaning leaving my vertex to be 1 from the x value above, right? And then 20 from the output value. And again, that should check with what I already knew to be the case from the vertex form that we happen to already know for this equation. All right, and really quickly, I want to show you how to graph from standard form. So just like with other things, I think it's easiest to start with the vertex. So we'll plot the point 120. Remember that we have this axis of symmetry that's running down the middle, and we know that the y-intercept here is going to be 4. In this case, we could have also found that by going down 1 and over 16 on this problem. So we could have gone down 1 and over 16. That would have gotten me there. Remember that this axis of symmetry means these same points exist on the other side. So if there's a point there at 0, 4, there's also going to be a symmetrical point at 2, 4. And this is going to create this super, super steep parabola. Remember, this is quite the stretch that's occurring here. All right, now everything we've done so far, you need to have really, really, really good notes on so that you could work those similar type of problems. And then this last thing I'm going to make sure that you take really good notes on. We're going to talk about how to write equations. When they give us points, but they don't tell us what the vertex is or anything else that would let us like really plug into a formula. There is a way to do this without your calculator. You could write a system of equations. You could solve it using a matrix. But personally, I just think that that makes honestly 0 sense. You're going to have a calculator, I think, on most questions like this, and it makes a lot more sense to use the calculator to do the work for you. Besides the fact that this is a skill you need in other aspects. So we're going to talk about how to find quadratic regressions using equations. And if it were me, I would copy these questions down, these points, and then I would go ahead and pause and copy down these directions, and then get your calculator out so you can actually push the buttons and follow along with me. Okay, before we actually walk through these instructions, I want you to clear your memory, so you may need to make one more note off to the side. You're going to hit second, plus sign, 712. And if you read what that says, it's just going to clear all the RAM on your calculator, which will basically reset all your settings. Okay, the screen that you should be seeing when you go to do that looks something like this. So option 7 says to reset. And we'll come back to this screen here in a minute. All right, so now you're going to follow this next set of instructions, which say to do stat, edit, and you're going to enter x values into L1 and y values into L2. The stat button is right here. I'm circling it in yellow. And then edit should be like the very first thing in that list. And L1 and L2, the screen that you're looking at, should look something like this screen right here. You will be putting in the x values for the 3 coordinates that we have. This is just a screenshot from another problem. All right, so x go in L1, y go in L2. You hit enter to input that value. And then it will take you to the next line. All right, now we're going to hit second quit to clear the screen. So quit is like right here above the mode button. So if you hit second quit, that will take you out of that screen, but won't delete anything that you have in there. All right, that was this. All right, now we're going to go to stat once again, and we're going to do, in the calculate menu, we're going to pick quadratic regression. So that same stat button. Now you should be looking at a screen, now you should be looking at a screen that looks like this. Notice the calculate menu is over here, like to the right. And then quad reg, in this calculator looks like option 5. I'm pretty sure for most of them it's going to be option 5. And now it's going to ask you a series of questions, and you're just going to hit enter on those to verify that all the settings are correct. And it should give you an output that looks something like this. Now, your output should not say this. Yours should say, for this specific example, A equals 3, B equals -6, C equals 8, and it should tell you that R squared should equal 1. All right, so let me help you interpret like what that means. They tell you the standard form, so they're telling you just to what the coefficients are. So in this instance, y will equal A, which is 3, x squared, plus b, so -6, plus c, bx, plus c, so plus 8. So there's my equation. And what the r squared tells you is that what you've been given, it tells you like how close it is. So this r squared being 1 is kind of like this being 100% accurate. So it's like, in this instance, this line is a perfect fit. And we'll talk about maybe sometimes when that doesn't happen. All right, and then the last thing you need to know is how to clear your list. So sometimes you don't want to clear all the settings in your calculator, you just want to clear the list. And so to do that, we're going to go back to that second plus sign menu for the memory. And this time we want to choose this option 4, which is clear all lists. And that will just clear your inputs, but it won't clear any of your other settings, which is what you need in this instance.